right, here it is, everyone. It is my annual winter forecast. Every day, every weekday, I post a video I call Weather for Weather Geeks. It's the area's most geeky, in-depth weather forecast video. And this video, covering the winter forecast, will be kind of in that same vein. This is for the weather nerds out there, the diehards, if you will. It's also for people who just need a lot of detail or want a lot of detail in their weather forecasts. I'm restricted by time on TV, but not in videos like this. So in that spirit, let's get to it. Just a warning, this will be a long video. If you are more the kind of person who just wants the quick and easy version of this forecast, the to-the-point version with you don't need all the extraneous details, be sure and check out the TV version of this forecast on wfmj.com/weather. I'm also going to be posting this evening a blog version of this forecast. If you're a little bit more of a reader, that will be something that you definitely want to check out. I'll link to it on social media as we go through the evening. All right, so here we are knocking on the door of the winter of 2022-2023. We're going to cover a lot of ground in this video, but before we get to the actual forecasting part, let's take a look backwards and to talk about the winter of 2021-2022. I'm going to throw a lot of numbers at you in this video, and all of these are valid at the Youngstown Warren Airport in Vienna in Trumbull County. This is where our official observations are taken, and so all of these numbers are valid for that location. Now, I know that snow, even to some extent temperatures, but especially snow, can vary quite a bit throughout our area. But officially, at the Youngstown Warren Airport last winter, we had 60.8 inches worth of snow. The 30-year average snowfall for that location in Vienna is about 67 inches or so, and so it is about 7 inches shy of the average. The temperatures last winter, when we talk about winter, we're talking about meteorological winter, December, January, and February. The temperatures last winter at the airport, 1.2 degrees above the average. May surprise you that last winter was a warmer than average winter because, yeah, it got pretty cold for a while in January, but winter last year started out very warm. In fact, it was the fourth warmest December on record. December, I should say, of 2021 was very balmy. It came with little snowfall because it was just too warm, but then winter started to kick in January, and particularly in the second half of January. It was nothing earth-shattering, but we had 10 consecutive days in which the temperature did not get above freezing. We had snow on the ground for at least a few weeks in most locations. Winter started to ease up in February. We had a back-and-forth month, and actually winter came to an end fairly quickly. As we got into March, it was actually a fairly mild March, which is always nice to see after a long winter season in our area. We do these winter forecasts every year in early November with an update in December. How did last year's forecast do? Well, it was one of our better ones. We had a wetter than average winter, which we expected. And when we talk about wetter than average, that's total precipitation, counting all types of precipitation. But despite it being wetter than average, it was also a little less snowy than the average. Both of these things we expected last winter. So I gave those aspects of the forecast an A. Above average temperatures, we expected that last winter, but we also expected December to end pretty cold last winter. That ended up being wrong. The cold waited a few more weeks until the second half of January to really settle in. So we got the timing a little wrong, but the overall flavor of the winter was pretty good in our forecast issued 1 year ago. Boy, are we due for a tough winter, though, because we've now had 7 consecutive warmer than average winters in our area. Now, the winter of 2017-18 and 2020-2021, they were pretty close to average, but they still were just a little bit above the average. And so we really haven't had a legit cold winter since the back-to-back cold winters of 2013 and 14 and 2014-2015. Snow has also been fairly middling of late. We've had 4 consecutive winters with below average snowfall. We had above average snowfall in the winters of 2016-17 and 17-18, but we've had 4 consecutive years of below average snowfall now. This stands in kind of stark contrast to some of the snowier winters we had earlier on this century. Ever since 2002, the snowy winters really outnumbered the opposite of that through about 2014-2015. But ever since the Super El Nino of 2015-16, we haven't had a whole lot of snow compared to average in the winter seasons. Came up with a list of the top 10 what I call worst winters in our area. The combination of total snow along with temperatures may surprise you. Some recent years are on this list. A lot of people around here who have lived here a long time remember the harsh winters of the 70s, and we did have a few. But actually, we've had more frequent harsh winters in the 21st century. including 2010, 2011. 119 inches of snow at the airport that winter, with temperatures about 4 degrees below the average. The polar vortex winter, when that term kind of came to prominence, in the winter of 2013 and 14, we had 90 inches of snow and temperatures even colder than a few winters earlier, 4.4 degrees below the average. Now, the winter of 76, 77 was amazingly cold at 9 degrees, 9.1 degrees cooler than average, although not as snowy that winter. We had 56 inches. The following winter was pretty tough. We had a tough one in 2014, 2015. A few more relatively recent years, pardon me, on this list, 2002, 2007, and 2006 as well. All right, so can we do this? You know, meteorologists, weather presenters, weather forecasters, we take a lot of incoming fire. You have to have a thick skin in this business because there's a lot of skeptics out there, a lot of people who lob things our way that they kind of think they're being creative or original by saying, oh, it must be nice to have a job and be right half the time, and things like that. I've heard those things minimum 4,000 times in my life. But the truth of the matter is, weather forecasts, for the most part, while there's always going to be misses, weather forecasts for the most part are highly skillful in the short term. These seasonal outlooks are not as skillful as these short-term forecasts, but there is skill in this. There's a lot of science that goes into this. Maybe getting a little bit harder, though, because of the fact that the oceans are much warmer than they used to be. We look at a lot of ocean data when coming up with these forecasts. The atmosphere, also much warmer than it was several decades ago, and that makes it harder to rely on past data from when the Earth and the oceans were quite a bit cooler. So how do we make these forecasts? The secret sauce, if you will. Yes, we look at computer models just like we do when we make these short-term 7-day forecasts, but we rely on something different in these seasonal forecasts, and it's the number one ingredient. It's analogs. Looking back at past years that had similar ingredients that we think we have this year, and then seeing what happened during those winter seasons. Now, I just mentioned this is getting harder because it's hard to rely on analogs that are more than, say, 30 years old. We look at stuff that's more than 30 years old, but it's hard to rely too much on winters from the 70s and earlier, say, even the 80s and earlier. But we do look at computer models as well, and some of this comes down to experience, intuition, learning from past mistakes. I've been making these forecasts, these winter forecasts, for 8 or 9 years now. I've learned a lot of lessons the hard way, and so does every other forecaster who makes these, long-range outlooks. All right, so key factors heading into this winter. This is a lot of alphabet soup, a lot of acronyms here. We're going to go through a lot of this. We're in a La Nina again this year for the third consecutive year. That's pretty rare. PDO, QBO, IOD, AMO, MJO, a lot of alphabet soup here. We'll try to explain a lot of this. We also had a volcano eruption in the Pacific Ocean 10 months ago that, believe it or not, may have some impacts on the global climate as we head into the winter in the northern hemisphere. All right, so I mentioned we look at the oceans. We look at all of them. Your eye is certainly drawn in this graphic to this big stripe of blue. This is La Nina. La Nina is the cooling of the waters in the equatorial Pacific. Our eye is drawn there. We also look at the northern Pacific, where it's cool here and warm right here, right now. We look at the western Pacific and the Indian Ocean, in particular this warm zone here, and relatively cool water closer to Africa. That dipole, if you will, warm water north of Australia, cool water off the coast of Africa, can be important, and we'll talk about that later on in the video. Also, very warm water right now compared to the average in the northern Atlantic Ocean. All of these things are important, even though El Nino or La Nina tends to be the top dog. So let's talk about some of this. This graph is what we call the AMO, or the Atlantic Multi-Decadal Oscillation. This is an oscillation, or a warming of or cooling of the Atlantic waters, the northern Atlantic waters, on a decadal scale. So this doesn't flip-flop every year or anything like that. This tends to occur over multiple decades. There can be variations from year to year, but you can see there's big chunks here. Right now we're in the warm phase of the AMO. We were in the cold phase from roughly, the early 60s through about 2000. We've been in the warm phase of the AMO since about the turn of the century. Now, you'll notice there's some blue here. Occasionally, this oscillation does turn negative or cold but that's not the long-term trend. Right now, the long-term trend or oscillation phase that we're in is the warm AMO. Why is this important? Well, warm water in the northern Atlantic can increase precipitation across our part of North America. And what I'm showing you here on this graphic is snowfall every year, calendar year, going back to the early 60s. All the years are at the bottom. I want to draw your attention to what's happened since the turn of the century. Now, the last few years have not been particularly snowy, but generally, the last 20 years have been snowy. Long-term trends are for more snow since about the turn of the century. Some of this is probably due to climate change. We've not only seen more snow, but we've seen overall precipitation trends heading in the upward direction year-round over the last 20 to 25 years. Some of that is climate change. Warmer atmosphere holds more water. It can precipitate more. Some of this probably has to do with the warm phase of the AMO increasing our precipitation and snowfall amounts going back since the turn of the century. All right, so the relationship, going back to La Nina now, the relationship between La Nina or its opposite, El Nino, and our winter seasons. We typically have bigger impacts from El Nino than La Nina. Typically, that's not always the case, but you see more red boxes here. This is the list of coldest winters on record for our area and warmest winters as well. All the red boxes are El Nino winters, the blue ones are La Nina. Oftentimes, when we have a really cold, harsh winter, El Nino is involved. The top 10 coldest winters, we have, let's see here, 6 El Ninos on this list. It was neutral 3 times, and at the bottom of this list, we had a weak La Nina. The warmest winters, there's a little more variety here. Yes, there are a few El Ninos, and when we have a strong El Nino, that does tilt odds in favor of a warm winter. Weak El Ninos can go the opposite way. But when you have a real strong one, typically it's going to be a pretty warm winter. But La Nina does show up on this list a few more times. Weak and moderate La Ninas, even one strong La Nina on this list of the 10 warmest winters on record for us. Not every La Nina or El Nino is built the same way, though. Some of these La Ninas, or its opposite, El Nino, can be more centered in the eastern Pacific, some in the central Pacific. In other words, the coldest water compared to average can either be banked up against South America in the eastern Pacific, or the coldest water may be pooled more in the central Pacific. That's important. If it's a east-based La Nina, this is kind of the composite that you get when you factor in all those years, you kind of put them in a hopper and get an average. This is what the map looks like for winter. Colder than average temperatures out here and warmer than average temperatures favored near the East Coast, and we fall somewhere in between. When it's a central-based La Nina, the map looks like this, the bottom one. Warmth definitely more favored in those central-based La Ninas east of the Mississippi, and the west, the cold I should say, is centered more towards the West Coast and the Pacific Northwest. Now, of course, there are exceptions, but this is an average or a composite of all the recent, going back a handful of decades, central and eastern-based La Ninas. All right, so another one of those alphabet soup things I talked about, the QBO, the quasi-biennial oscillation. This is a river of wind in the stratosphere, way above our heads, way above where the airplanes fly, above what we call the lower atmosphere. This is up near the stratosphere, and this belt of winds circles around the equator, but it changes direction roughly every 14 months. All right, so what? What does this have to do with our winter weather? Well, it's been shown that the direction of this oscillation, this QBO, is important for us in the winter. When it's in a westerly direction, that tends to increase the chances for mild weather in the eastern U.S. because a westerly or positive QBO tends to lead to a pattern that doesn't disrupt the polar vortex as often. That polar vortex, which likes to sit above the North Pole, as long as it's up there above the pole, it's going to hog most of the cold air. When the polar vortex wanders or weakens or gets a little wobbly, then spokes of cold air can come south with more frequency. A westerly QBO prevents that from happening as often. When the QBO is easterly, the opposite. That increases the chances that the polar vortex gets weaker, it gets a little funky, gets a little wobbly, and it can start shoving colder air southward with a little more frequency. Well, heading into this winter, we're in a westerly or positive quasi-biennial oscillation. So that's a feather in the cap of hedging towards a warmer than average winter. So that's one thing we look at in addition to the oceans. What's going on in the upper atmosphere is important. All right, so it looks like I have this graphic on here twice. Didn't mean to do that. So this is just that AMO thing I showed you earlier. So we'll skip past this graphic and go to another acronym. Lots of acronyms. This is the MJO, or the Madden-Julian Oscillation. This is a cluster of thunderstorms which propagates in the equatorial regions of the Indian Ocean and the Pacific Ocean. Kind of like that QBO. You may be asking, so what? All right, well, this semi-organized cluster of thunderstorms, or convective area, it's so big, and sometimes gets so big and so organized, that it can have an influence on the jet stream farther downstream into the Pacific and eventually into North America. So this is a semi-permanent feature. This is constantly kind of circulating through the equatorial regions. Sometimes it's pretty weak, sometimes it's pretty strong. When it tends to be strongest over Indonesia and areas north of Australia, this tends to increase the chances of warm weather in the eastern U.S. because it does things to the jet stream that promotes ridging across the eastern U.S. when the MJO is here. Now, when the MJO goes into a phase that's a little more centered in the kind of west central Pacific, this tends to be an area in which the downstream impacts favor cooler weather in the eastern U.S. During a winter season, we're going to see the MJO go into all these phases. But which phases does it favor? Well, remember I showed you on that water temperature map, there's a lot of warm water north of Australia. This MJO is going to want to feed on that warm water, and so it's going to want to hang out there, I think, a little more frequently than meandering into the Pacific, where it's going to encounter some cooler water. And so therefore, I think we're going to see this phase of the MJO, where it gets out in the Pacific, a little bit less frequently. It's going to happen sometimes. It's going to get cold sometimes. But the MJO, I think this winter is going to favor some of those phases, if you will, that kind of tilt the odds in favor of warmer weather in the eastern U.S. Now, you may be already saying, hey, Eric's going to call for a warm winter, right? Well, maybe not so fast. We're going to talk about the forecast here momentarily. Talked about analogs, looking back at past years. Here's a look at my top analogs for this year, and I kind of differentiated between the top of the heap and some of the analogs that are okay, but maybe not as good as some of the others. But this is the list. There's 9 years on here. There are 2 cold winters, 2010, 2011, which was really cold. In fact, the most harsh winter on record. It's on this list and towards the top of the list, actually. 2008, 2009, pretty tough winter. 86.5 inches of snow, 2.3 degrees cooler than average. But the other winters on this list, while there are no what I would call blowtorches on this list, like 2015, 2016, 2011, 2012, 2019-20 was a blowtorch type of winter. Those years are not on this list, but there are several mild-ish winters on this list. We also have 1, 2, 3, 4, 5 winters in which snowfall was below the average on this list. All right, so that's my list. When you look at this list and throw it in the old weather hopper and get an average of all those years on the list, and you also what I call weight some of those years, put more emphasis on some of the top years as opposed to the bottom of the list. This is the map that you get, where colder than average temperatures are favored across the Pacific Northwest and especially down into the upper Midwest. And while we do have some blue and green around here, the odds are not as strong, or the signal is not as strong, if you will, for widespread sustained cold this far to the east as compared to off to the west in places like Chicago and Milwaukee and Des Moines and Minneapolis. That's the way the analog composite looks in terms of temperatures. In terms of precipitation, there's a stronger correlation in the precipitation department on a national scale than temperatures. You see some of these deeper reds. It's very likely it's going to be a drier than average winter in the southern tier of states. Very strong correlation. It's very likely it's going to be a wetter than average winter in parts of the Pacific Northwest. You'll notice we don't have a lot of coloration across the Great Lakes in the Northeast. Now, that being said, even though this is the analog composite, there's a lot of years, and you get an average. In some of those years, we had some pretty wet winters, including last year and even the year before. Not particularly snowy winters, but wet winters. So even though you don't see a lot of green or above average precipitation on our composite map here, I do tend to favor a little bit of a wetter look to the winter here locally than for when you throw in all those years and get kind of a composite look. All right, looks like I have another repeat graphic on here, so we're going to skip this and go to what I would deem kind of a wild card as we head into this winter season. January seems like forever ago, right? But earlier this year, you may have seen on the news, there was a big volcano eruption in the southwestern Pacific. This is what's sometimes called a submarine volcano because it's mostly underwater. This eruption, typical volcano erupts and spews a whole bunch of ash into the atmosphere. It can actually have a cooling effect on the atmosphere because there's so much ash, it blocks incoming solar radiation. Well, this type of volcano, the eruption occurs under the surface of the water in the ocean, it can spew more water vapor than ash into the atmosphere. A ton of water vapor. And this is starting to show up in some readings in the upper atmosphere in the northern hemisphere as we head into the winter season. It can be speculated already that worldwide precipitation trends this year might have been influenced by the presence of excess water vapor in the atmosphere as a result of this volcanic eruption early this year, the very beginning of the year, in the southwestern Pacific. Will this have an impact on the northern hemisphere winter? Will it increase precipitation? Will the presence of more water vapor high in the atmosphere do something to the polar vortex and perhaps strengthen it some? Maybe. This is low confidence, but it's a wild card. Might learn some things about this winter. It'll be interesting to see how it plays out. It's not something that I'm going to hang my hat on, but it's possible that some impacts could occur. All right, so let's get to the forecast. We're going to start out nationally and then get to a little bit local. This is a look at my national temperature forecast for the winter season. Colder than average temperatures definitely favored in much of western and central Canada and the upper Midwest of the U.S. Warmer than average temperatures are favored in the deep south. Around here, we can see it going either close to average or somewhat cooler than average. I don't see a harsh winter all that likely around here, but we do have a chance of seeing a colder winter than we've seen in a lot of our recent years. Precipitation trends, again, strong signal for dry weather in the south, but wetter than average conditions I think are likely, particularly from our area on north and west into the lower Great Lakes, into parts of interior New England as well. All right, locally, snowfall. As you know, we don't have a real big viewing area, not as big as some big markets like Cleveland and Pittsburgh, but we have a viewing area that does have a lot of variety when it comes to snowfall totals because of our proximity to Lake Erie. We live in the secondary snowbelt in parts of our area, and so amounts can be much higher in our northern viewing area than southern viewing area. You see some of the hot pinks as you get up into Trumbull and Mercer counties. We're talking 60, 70, 80 plus inches worth of snow. All those numbers compared to average are near average, maybe somewhat above average. Off to the south, once you're down into Mahoning County, place like Canfield, Boardman, Ellsworth, heading down towards North Lima, New Middletown, places like that. 40 to 50 inches, pretty likely, I think, and in some of that area, that's a little bit above average. Once you're down into Columbiana County, 25 to 40, and all of that's a pretty big range, but all of that is pretty close to the seasonal average and maybe in some spots a little bit above. The reason for this kind of minimum right in through here, this is kind of the shadow or kind of the footprint, if you will, of the Mahoning River Valley. So amounts tend to be a little bit lower in, say, downtown Youngstown than off to the north into Girard and Liberty, and also off to the west in parts of the Canfield area, Austintown, and on to the west over towards Berlin and places like that. The river valley, the lower elevations, tends to reduce snow totals a little bit in those areas that are close to the Mahoning River. So again, all these numbers don't stray too far from the average, but some of them can be a little bit above average. I would expect these snow totals in some parts of our area to be the highest that we've seen since the winter of 2017-2018. Do I think we will see a tremendous amount of snow this winter, something on par with 2010, 2011? No, I don't think so. We'll talk about snow a little bit more in just a second, but let's go back to temperatures. The maps I just showed you, those are the most likely outcomes. What are the odds of different types of outcomes this winter. Well, we think the strongest odds temperature-wise are kind of tied between near average and colder than average. And so from anywhere from -4 to +1, the odds are about the same. The odds of a warmer than average winter, kind of like we've had over the last few years, lower, but not negligible. It's a 1 in 4 chance. The odds of an extreme winter, either on the warm end or the cold end. So up here, this would be a winter like 2013-14 or 2010-2011, 1 in 10 chance. Even lower chances of a blowtorch kind of a winter like we had in 2011-2012. Back to the snow department. The strongest odds are for near average snow, say between 90% and 110% of average. But just behind that, the second most likely outcome is an above average season in the snow department. Behind that, the most likely outcome is a below average season, and then the extremes, again, pretty small numbers. Somewhat higher odds of a really snowy winter than a really paltry winter in the snow department. But both outcomes are not very likely at all. All right, so a lot of us, with the exception of, kind of the hardcore weather weenies, a lot of us just remember what happened last winter. We don't have a memory of what happened 10 years ago and 5 years ago, things like that. So let's compare to this winter's outlook to last winter. I think compared to last winter, this will be a little bit colder and a little bit snowier than last winter. Extreme? No, I don't think so. It's hard to get an extreme winter when you have a La Nina set up like this, but it can be colder than the last few years. And I think for a lot of us, the biggest thing we'll notice this winter is the colder month of December. We had the 4th warmest December on record last year. This December, I'm not expecting it to be an extreme December, but I wouldn't be surprised if it ends up colder than average. And even if it's an average December, that would still be a good 4 or 5 degrees colder than last December. That's a big change. With the colder weather probably comes several opportunities for some snowfall in the month of December as well. This is a tricky forecast. We have some competing signals. I think the east-based La Nina is a feather in the cap of it being a colder than average winter. We talked about other things that are feathers in the cap, if you will, of a warmer than average winter, including the QBO, the configuration of the waters in the northern Pacific can be in the Indian Ocean as well. Those can be things that might tilt you the other direction towards a warmer than average winter. But I think a pretty stout east-based La Nina is going to win more battles than some of those other factors, at least during the first half of winter. La Nina is going to fade late in the winter, allowing some other things to try to take over. If that fading occurs quickly, winter might still be go pretty hot and heavy well into February. If La Nina doesn't fade all that quickly during the last half of winter, if it's still kind of a player, then we may turn pretty warm pretty quickly at the end of the winter and into early spring in March. That is a low confidence thing right now, but kind of depends on the progression of the decay, if you will, of La Nina. I almost made it to half an hour in this video. I'm going to stop talking now. Thanks for hanging with me on this long version of the winter forecast. Again, you can read more about the winter forecast on my blog, ericwfmj.com. We'll link to that on social media this evening. Make sure you're following me on all my outlets, including on YouTube. Have a great day, a great night. Thanks for watching, and we'll be updating this forecast in probably about a month during the kind of the middle portions of December.